Welcome back to part 2. This tutorial is for beginners to Unreal Engine. We're going to create another model for another type of collectible. We're going to work on some materials to add color to the models. We'll dive into some user interface and some programming for collecting these collectibles. Let's just step back into the collectible base. Because we want to have the mesh floating above the ground, we want to add to this some value, say around 150. So it's going to be 150 units plus 0 to 100. If we were to test this now, select all of them by holding Control and then hit the End key. It will place them all on the floor. Let's use Unreal Engine to create a couple meshes. In the content browser, I'm going to create a new folder, _mesh, and then go to this drop-down and select modeling mode. In Create, let's create a cylinder. Place that somewhere in the world. We will rotate it 90 on the Y, raise it up a little bit off the ground. From here, we'll accept. In the mesh settings, we'll do triangle edit. We'll select, this is for faces. We'll just select these faces on the end. Make sure none are selected on the sides. Then we will take this little gizmo on the red line here and just push that closer together. Now with the entire object selected, take this bracket and scale that a little bit in. We can accept. Now we will find it in our levels folder. It's placed next to where our level is. It's in generated. It might have your like a username and you'll find it in that folder. We can rename it to mcoin. This is future me and I named the meshes incorrectly. I'm going to change that right now, and instead of M, I'm going to put S for static mesh. So just go ahead and make that change. M is for material and S is for static mesh. As this tutorial progresses, the naming's going to be incorrect, but in part 3, it will be corrected. If we go into our collectible, static mesh, we can search for coin, rotate it. Now we have all these coins. Let's add a little color to it. At the content folder, we'll create another new folder called materials. In the materials folder, we'll right click, create a material, M base. We'll just create a base material, open that up. Materials are very powerful, but for this purpose right now, we will just assign a color. By pressing on the 3 on the keyboard and clicking with the mouse, we'll create a vector 3. This will have the components of an RGB. So out of the combined RGB node, we'll just drag that to the base color. Double click in the box, we can select the color that we would like. I'll make mine like a gold, somewhere between yellow and orange. And then we can just hit apply. If we want it to be shiny, like a coin, press 1 on the keyboard and click anywhere to create a float. We'll plug this into the metallic. From 0 to 1, 1 being the most metal looking, I'll make this a 1, and that is a fully metallic looking material. And then to make it shiny, again, press 1 and click. We're going to drag this into roughness. 0 is the shiniest, so that's like a chrome. I'll make this like a 0.25. So we have a shiny metallic material. Hit apply. Double click on the mesh that was generated and we'll come to the mesh editor. In the material slots, we're going to change this to M base. There we go. Hit save. Go back to our level, and now they are all shiny looking coins. What we're going to do is create a star model using the in-engine modeling tools. So if we go up here to modes, selection mode, and go to modeling, In the create options, we're going to create a disk with 5 radial slices, which will create a pentagon. Just hit accept there. Hit R on the keyboard to get to the scale gizmo. We can make it a little bit bigger. Make sure to select the center box so they're all yellow. Then just click and drag, make it a little bigger. Then the easiest way I've found to do this is go to Mesh, Triangle, Edit. In the selection filter, we want to turn off the points and the faces and just select edges. Holding Shift, we're going to select all of the edges. With them all selected, we will hit the Split Edges button. Then we will turn on points and turn off edges. And we're going to hold Shift again and select all of the center points we just created. With those selected, in the center of the gizmo is a black box. Click that and just drag it in until you get a star that looks good to you. Then we can take the center point using the blue line in the gizmo, drag it up. It'll have some depth to it. We can hit accept. And now we have a star that's mostly a flat plane. With our star selected, then go to the model button, hit the mirror button. We want to mirror and append, and we'll use the down preset here to mirror down. If yours is oriented a different way, you may need to use a different one. But now that I've done that, it's mirrored below. I'll just hit accept. So that looks pretty good. We can get out of modeling tool here. So this mesh, click on it. And in our details panel, hit this magnifying glass. We'll find it in a folder. We can rename it to M star. We can also create a meshes folder. Then I'll go to my generated shapes and drag them to this meshes folder. In the meshes folder, we can also categorize the meshes by what they are. So I might call these collectibles, move those into that folder. When moving things around in the content folder, the engine creates invisible redirector files. After doing anything that changes file locations, it's a good idea to right-click on the content folder and update redirector references, just to make sure everything is cleaned up. All the invisible files are removed. With the star, let's assign a material to that. Let's go back into our material folder. This is a base material that we created for the coin. However, it's not easily reusable. If I was to click it and drag it, I could put it on the star, and that works great. But let's say we want to change the color or something. Let's go back into this base material. What we're going to do is parameterize these options so that we can reuse this material for many different objects. Right-click on the vector 3 here, convert it to a parameter. We can just call this color. Right-click on the float. We'll call this metal. Do the same here, roughness. And we can parameterize some other things as well. Press 1, create another float. Specular. We can also copy these nodes, so I can Control C, Control V, press F2 over the name here, name this to emissive color. And what I want to do for the emissive is also have a strength. So I'm going to create a float, parameterize that to emissive strength. By default, I'll keep the strength at 1. Now dragging off the color, search for multiply, or use the asterisk. Multiply comes up just like that. Plug both of those in, and then plug this into the emissive color. Actually, I might make the strength 0 right now. 1 will make it glow, and 0 doesn't make it glow at all. Another thing we may want to do is create a gradient, a linear gradient. And if we multiply off of this, we can right-click on the multiply node and preview it. We can see it starts at black and goes to white on the horizontal axis, which is the U gradient. And if we did it with the V, change the type of model to like a box, and that's a gradient from top to bottom. We can multiply this by the color and then put the color into the base color. Stop previewing this node. With the gradient, let's do a cheap contrast. We need a float for the contrast amount. We'll parameterize this, gradient control, and then we'll plug the result into the A like that. Stop previewing the node. We may want to brighten it up as well. If we just do an add node with another float, we could do a brightness and then plug that into the multiply like that. So the add node will brighten things up or darken things. It raises or lowers the overall value of the gradient. A little extra control on how things are going to look. Also, we want to include a linear interpolation node. Drag off the V and type lerp. So we can just make the U gradient the A, the V gradient the B, and the alpha will be the blend between the two. Drag off this and put that in the contrast node and create a float parameter. Call this one strength. I'm going to put the control into this one and the strength into this one. We can hit apply and then save. Now back in our content browser, right-click off of the material and select Create Material Instance. Name it MI for Material Instance, and this will be the coin. Selecting the coin object and the static mesh component, double-click on the coin static mesh. We're now going to change this default material to the coin. We can hit save and close that window. Open up the material instance for the coin. Drop down the scalar parameters here and the vector parameters. The vector parameters are the colors and the scalar parameters are all of the floats. If we want to change something, just check it and we can start messing with it and seeing how it looks in the world. Up the brightness a little bit. That actually looks pretty decent. So playing with these values, you can do whatever looks best for you. I'm going to hit save. Now I'm going to also create a material for the star. Right click on the base, new material instance, MI star. Select the star, double click on the actual mesh for the star so that this changes the default material, not just the actor that's in the world. Search for the MI star, save that, open up the star instance. I want to change the color, the roughness, and the metallic. The metal is going to be 0. Roughness could be like 0.5. Color, I want it to be more of a blue. Now it's not changing here because when I dragged off of my base material, I set the material of the object in the world to this base. If I go into the detail panel, there's this arrow here, which will reset it to the default value. And since we set the default value to the material instance, it's going to change it to the star material. So that's why we apply the material instance directly to the mesh. A little darker blue, add some seafoam green for like an emissive. So I'm just going to save that. There's my blue star. If I go to my meshes, drag another star into the world, that's how it looks. Now go to our blueprints, collectibles, open up the collectible blueprint. If I change the static mesh from coin to the star, all of them change to stars. I'll just compile that and save. Let's just play this. So now we have some stars. But what if we want both coins and stars? Change this back to my coin. I'm going to set up a data asset. I'm going to create another folder, call it data. So I'm going to first select blueprint class. And in the all classes section, I'm going to search for data asset. I'm going to create a primary data asset. A primary data asset sets up the variables for the data asset, and then we will instantiate that primary data asset, select, just call it DA for data asset. This is my collectible data asset. Open that up. It's a collection of variables. We're going to have a mesh, so add a new variable. We'll call this the mesh. In the type, we're going to search for static mesh. In static mesh, create a soft object reference. Then create another variable. This will be a resource. We do not really have a type set up for resources just yet. The next variable will be an amount. This can be a integer or a float. The amount will be when the player collects the collectible, the resource, how much of it will they gain. So you might have some special coins where a red coin where you get 3 of them instead of the standard 1, something like that. Now for the resource, we need to know what type of resource it's giving us. Back in the tutorial level, so in the data section here, create a folder called enum, open that, right click, and in the blueprint section, enumeration. So collectibles. What an enum is just a list of items. So we're going to add one of them. The first one will be our coin, add another one, and that'll be our star. And you can create as many as you like. With that set up, we can now go back to our collectible data asset, and in the resource type, we can search for collectible, and there it is. Compile that and save. With these 3 variables, we can now go into our collectible blueprint and add a variable. This will be the data for the collectible. In the type, we're going to look for DA collectible. This will be an object reference. Go over here and make it editable and expose on spawn. Now I need to set up for each collectible their data asset. Back in the content folder, from here what we want to do is right click and in the miscellaneous section create a data asset. This is not a primary data asset, this is data asset that uses the primary asset. Selecting this data asset, now it's going to look for primary data assets and we can find DA collectible. Select DA collectible from it, so it'll look something like this. Right click on the coin and duplicate it, and we can set up one for our star as well. Opening up the coin, we have our 3 variables. We can drop down the mesh one and search for our M coin. The resource will be a coin, and by default, we'll get 1. For the star, we'll look for M star. This will be a star, and by default, you'll get 1. Let's say we duplicate the coin one more time and do a red coin. Open that up and maybe you get 3. However, the coin is not red. We need to be able to change the material. So to be able to edit the material, let's go back to our DA collectible and we'll add one more variable. This will be the material. And for the type, this is going to be a material interface. So a material interface will allow the material to be a base material or a material instance. Because materials could have textures which are fairly heavy, I'm going to create a soft reference to that as well. And I'm going to drag it up under the mesh so that it's ordered this way in my data assets. Compile that, save. Now if I go back to the coin, there's a material slot here. And if it's a null value, we can have a check for that so that it uses the default. For the red coin, we do not have a material for it yet. Go back to our materials, duplicate the material instance, call this red coin, and then we'll change the color to a red. And it has no emissive, so we don't need to worry about that one. In the red coin data asset, now we can search for red coin, and we'll save that. So our data is set up for these collectibles. We can close all of that. In the collectible blueprint, let's go to the construction script. When this actor is first loaded into the world, it will run this construction script. Click on the static mesh, drag that in, then pull off the static mesh pin, do set static mesh. So what this is doing is if we select the static mesh on the right side, you can see in the static mesh section, we've already set it to the coin. This node is going to replace what is here with whatever we tell it to replace it with. Take the data variable, drag it in and do get data, drag off that pin and do get mesh, which is the name of our variable. Then from here, we can take the mesh pin, the soft reference, and drag it into the new mesh pin. Now what this is going to do is create a conversion node. It's going to convert a soft reference into an object reference. And what to keep in mind with this conversion pin is this can cause hitching in the game if it's a large mesh or material. So if it's a super high poly mesh, it could cause a hitch in the game. However, this being the type of actor it is, I assume it will be loaded in during level construction because most likely they will be placed in the level. This hitch will be largely invisible because it's happening during the loading of the level. If we were to spawn an actor in the event graph, or it's something placed in the level that will be streamed in and out during gameplay, for example, the player is running closer to it and there's streaming set up where it will be streamed in, we will not want to use a conversion node like this. We would want to do an asynchronous node, but that can only be done in the event graph. A unique property of the construction script is this is run in the editor. So whatever we do in the construction script, we will see take effect while we're creating the game. This mesh will be updated in the editor. Whereas if we're doing it in the event graph, we either need to hit the play button so that the game is running, or we can tag an event to be run from the construction script. However, it will not run time-based nodes. So this coin, if I change it to the star, it will change, and it's doing that in the editor. Now, if I was to move this into an event, as an example, I'll create a custom event. If I do it in the event graph, I can select the event, check this box, call an editor, and then go to the construction script and call that custom event. This will also work. But then if I put, let's say, a delay, which is a time-based node on it, now when I change it to the star, it is not updating. Let's say we want to asynchronously load the mesh, something like this. When it's completed loading, and then we have to cast this, we could asynchronously load it here, but it will still not change it. So one other option we could do is in the construction script, we can have is packaged for distribution. Hold the B key on the keyboard and press anywhere for a branch. If it's not packaged, that means we're in the editor, so we'll do the construction script, and if it is, we will do the event graph. So now it is using the construction script. And then we would call this something else like setup actor, something like that. But to simplify for our purposes, I'm going to remove all of this and get rid of this event in the event graph. Stick to what's in this construction script here. Now what we're going to do is set the material for this. Off of the static mesh variable, we're going to do set material. And then off of the data asset, we're going to get material, and we can do the same thing here. So that will set the mesh and the material. Compile and save. Select one of my coins. And on the right, we can see my data asset variable is here. Let's drag the red coin onto it. And there we go. We can change it to a star or back to a coin. They default to these coin meshes because the mesh is set up to be the coin. Now we can change the scale. That actually could be a good thing for the data asset. Let's say scale, and for it to be a uniform scale, I'll just create a float. Call it mesh scale, put it somewhere there. And then we also want to change how it's oriented, because some meshes, the default, they're laying down, and this will be the mesh rotation. And this can be a rotator. So with those new variables, back in the data for the star, I want my scale to be 2. We should set some defaults. So for the scale, we want the default value to be 1. For the orientation, we have it rotated 90 degrees. So in my star, we're going to change that to 90 there. And the coin will also be 90. And the red coin will be 90. And maybe the red coin will just be a slight bit bigger. Now back in the collectible base actor construction script, we'll set up the scale and rotation. From the static mesh, we'll do set relative scale 3D. Double click for a reroute node to organize this. Put these down here, put the static mesh something like there. I'm going to drag off the data asset, get mesh scale. We're going to keep it a uniform scale, so all of the axes will be the same value. So off of here, we could just do make vector. And then in the make vector node, we could just plug in the float to all three axes. Lastly, off the static mesh, we can use this reroute node here. We'll do set relative rotation, another reroute node to organize this. Drag off the data asset, get mesh rotation, and we'll plug that in there. Add another reroute node to organize this, and there we go. That is our construction script. These 4 pieces of data from the data asset will affect the object here. So the stars are much larger. So now the cool thing with the data asset, the way we set it up, I could just drop this down and it's going to find all of my collectible data assets. So it's a short list that I could just select from. And if I wanted to change something, let's make the star even bigger, and then I save that. It's not going to update immediately in the world until it has to re-render something. So once I move it, it will become bigger. Let's make the stars back to 2. When it has to recreate the object, it will look at the new settings and do that. Let's go to our character blueprint. We have a variable for coins. Instead of a variable for coins, we're going to want to change this to a collectible. One thing we could do is set it to a map, change the type. So the first part of the map will be our resource type, collectible, change the type there, and then the integer for that type. Also the function, let's change the name to acquire collectible. For the input for this, let's have the input be the type of collectible. So this will again be collectible, and the amount that we are gaining, the type and the amount. That'll be a whole integer. So a map has keys and values. The left part of the map is the keys and the right side is the value for that key. We first need to get the keys, and we need to find what equals this value. We need to plug the keys in like this. If it does find something in the map, it will have a valid index. So from here, let's check if it's valid. Is this a valid index? Hold the B key and press to create a branch. We're branching off whether it's a valid index or not. Get rid of all this. Keep the print string. If it is a valid index, we want to, again, drag off the collectible and get the values. Set array element. We're going to use this index, and we're going to use this value for the item value. And if it does not find the key, then we're going to, I'll just drag another one of these. We're going to add to the map, and it's going to be this type and this value, just like this. Something like that. Let's create one more function. List our collectibles. Drag off our map. We'll get the keys and the values of the entire map. For the keys array, we'll do a for each loop. Get a reference for the values array, and at each index of the key, we'll get the value. From the enum, we want to get a string, enum to string. We now have this many of this type, and this here has a space. So this will loop through our collectibles and tell us how many we have. What we can do is now drag this in here and do something like that. Because we changed the variable, if there's an error here, just refresh the node and then try to compile, and it should work. Back in our collectible base, now we need to drag in the data, get my resource. I should have named this collectible for consistency. That can go there. Get amount. So this is the function we created in the first game character. We're just plugging it in here to transfer the data from the data asset. So once I compile and save that, now when the character runs over the collectible item, it pulls from the data asset what type it is, how much they're getting, plugs it into the function we just created. If we double click it, and then it adds to a map here the quantity and type that they have. And then we're going to print out what they have currently. So let's see if all of this works. Let's try a star. We have 1 star, and we have 3 coins. So one little mistake is in the character function here, I'm not adding the existing value. When it already exists, I need to get a reference from the index that it found, and then we're going to hit the plus sign and add that to the value from the data asset, plug that in there. Now it's adding what was already in the map to the new value that's being acquired. Compile and save, test it one more time. So slight issue with how this was set up because I forgot how maps worked a little bit here. Set array element doesn't work with map arrays, so we just delete this out. We're going to just do another add. It's going to overwrite the value automatically. So with this add here, we just put that there and get the type. This looks like it'll be a little messy here. So if we just do that, it should work, and then we'll plug that in there. So there we go. 3 stars, 3 coins, 4 coins. So now we have stars and coins accumulating properly. And because of the modularity we set up, we can easily create many more if we choose, and then set up data assets to have different types and visuals and quantities and materials. Let's say I want to add one more resource. Now it's very easy to do so. I simply go to data, enum, let's add one more. This one could be bricks. Then I can go to data, duplicate one of these data assets. I'm going to quickly model a box. Go back into the modeling tool, create a cube, go to triangle edit, select some faces, push it around a little bit until it resembles a rectangle. Squash it down. Once satisfied with the shape, accept it. Find the mesh in the content browser, rename it to S brick, then move it into the correct folder. Now that the mesh is created, go into the brick data asset that we had previously created, assign the mesh, go to the material folder, duplicate the star material, rename it to M brick. Then open up the brick mesh and assign the default material to be the one we just created. Then open up the material and we'll edit it to look a little bit different. Change the color. I'm going with something a little more orange. Then in the data asset again, assign the brick material. So with this particular mesh, we could see it's outside the collision capsule. Get my brick, add it back to the world, go to modeling mode. I want to go to X form and edit the pivot of the box because right now it's in a weird place. So I want to center the pivot into the middle of the mesh and accept that. That will move the box to the center of our actor. The next thing we could do is just edit the scale of the mesh here. Select everything with this button here, and I could make it 1/4 of the size, turn off snapping, something like that. The size seems good. Now if I go back to the data asset, I do not want to rotate this. Leave it 0 on the rotation. That should put it flat like that. So now I have coins, stars, and bricks. And because of the way we set up the blueprints, I should be able to just collect the brick. You can see it says 1 brick. So that's relatively a quick way to set up new resources or collectibles. We need to start adding some UI to show what we have. Create another folder, UI. In the UI folder, I'll create another folder. This will be the HUD, the heads-up display. This will be different than the menus, the main menu, settings, all the other UI stuff. This will be the character's heads-up display that shows the stats that the character has, resources they own, abilities, things like that. Now right-click anywhere, go to User Interface, select Widget Blueprint. We have some options here. We just want a user widget. It'll be the main widget. When it comes to UI, think of it in layers and small parts. The main is going to hold all the little pieces. Open that up, drag that up here. The first thing is go to the panel section. A canvas panel is commonly used. However, it is also the most performance heavy. Better practice is to only use an overlay panel as the root in the hierarchy here. The overlay will be the container for all of my other widgets. Now, go back to the tutorial level. Let's just right-click the widget that we're working on and duplicate it. This will be our resources panel. Open up the resources panel. Now, instead of an overlay, delete that. We're going to need either a horizontal or vertical box. I think I'll do a horizontal box. In the horizontal box, I then want a text, and I'm going to want 2 of these. So the first one, click on it and hit F2, name this resource, and the second one, quantity. With these text box on the right side, align center, and we're going to change this from fill screen to desired. With both text boxes highlighted, let's add some padding. I like maybe 7 pixels. To see visually how this might look, let's change the text here to coin or coins and put a quantity of like 10 or 100, something like that. Then go back to the tutorial level one more time. We could just duplicate this widget once more, the main one that has nothing in it. Let's call this the resource container. Delete the overlay again. Do one more horizontal box. This is going to be our resource container. Rename it on the top right and check is a variable. Also change fill screen to desired. Compile that. Now in the panel search, let's search for resource. We can find the other widget, drag that into our container, add a couple of them. And that's how it could look. Add some padding. If you want it to be a vertical, you can right-click the resource container and replace it with a vertical box, and then they'll be aligned vertically. I think I want mine to be horizontal, so I'll just undo that. Let's go back to the main widget, search for resource. Let's add the container to the overlay panel. If we select the resource container, we can either center it, align it to the bottom, bottom left, something like that, wherever you want it to be. Selecting the resource container, we can add some padding. This is going to be off the edge of the screen. I might use something like 50. Compile that. As we create more pieces to our UI, we add them to this overlay. So let's just say we had another type of thing. We can add it to the overlay. Keeping the padding the same will make it nice and clean, but up here could be health bars, other stats of your character. That's a simple way to start creating your user interface. Open up the player controller. In our game folder, we have PC first game. Open the full blueprint editor. So we haven't done anything in our player controller yet. Go to the event graph. We want to show the HUD when we possess the character. So we're going to right click in the event graph and search for possess. And we have these events, event on possess. When we possess the character, we're going to now create a widget. We're going to search for wMain. The owning player is going to be this player controller. Just right-click anywhere and type in self. Plug that in there. So we've created the widget, but now it needs to be viewable on screen. Drag off of this pin here and do add to viewport. So now when the player controller possesses the pawn, it will create the widget and add it to the screen. We should also get the reference to this and save it. On this pin here, right click, and we're going to promote it to a variable. Put that right in the middle here. Rename this variable to HUD or UI, anything that makes sense. In the category, let's change the default to UI, and now it's a categorized variable just to keep things nice and tidy. Then we can come down, create another event for unpossess, and let's say the character dies or player becomes a spectator or goes to a main menu or something like that. We can take this variable, drag it out here, and remove from parent. That will just remove it when we're no longer in control of the character. So now, if we go to the tutorial and hit play, we have our resources UI on the screen. Now we simply need to get these things talking to it. In the resources widget, let's go to the graph. I'm going to delete these nodes to tidy it up. Let's create a function here to acquire resource. We're going to add a couple inputs for this function. Name the first one resource, and the type will be that enum that we set up. Collectible. There it is. One other input for the quantity or amount, and this will just be a whole number, so it'll stay an integer. In the designer view, both of these text boxes need to be variables. So select both of them and check the is variable box. Now that we've done that, they show up in our graph. Let's start with the resource. Drag off the pin and type set text. So all the way at the bottom, there's set text with text in parentheses. Drag off that and do enum to string. Plug the string into the text node. And then for the amount, quantity, drag that off. Again, set text. Simply drag the amount into the text. If your resources are static and you know how many there are, you can do it simply like this and then change these widgets to what it is. If we want a more dynamic or modular approach, we can keep these empty and then go to the graph. Let's create a function in here and call this update resources. And we need an input. We'll make it the eCollectible type. We'll get our container variable. We'll see how many children it has. Drag off, type children, and we're going to see if it has any children. Press B and click to create a branch. Plug that in there. If it does not have any children, we're going to right-click, create widget, and we're going to create a resource widget. Then I'll just use another one of these here. Add child. We're going to add a child to the horizontal box. And then off of the horizontal box, we're going to search for set padding. Off of this pin, we're going to do make margin, and 8 was a good number based on what I did earlier. We're going to map this resource to the resource type. In the variable section here, add a new variable, resource mapping. Change the type here to eCollectible. Drop this down next to the variable type and choose map. And in the second, we're going to do widget object reference. Drag off of there and hit add. Plug this in here. Then off of the resource widget we just created, that will be the widget. And the resource will be the type. So now we know which widget belongs to which resource in our container, because we're going to be adding children to this horizontal box, and we need to know which one belongs to which resource. Where did this come from? Get rid of that. So if it does have children, On the true side, we can now take our resource map, get the keys, find. We're going to look to see if we already set up a resource widget. So we're finding if one exists. Pull off here and do is a valid index. Let's do some comments here. This here is container is empty. Add a resource to it. From here, if this is a valid index, then we do have a resource already set up. Add a return node. On the return node, we will get the reference to the widget. So this will be search for widget, make it an object reference, just make it resource widget, get the mapping, get the values from the map, and we're going to get this index that we found, and that will plug in to the output. We'll add the return node down here and also plug that in to the output. This output we will use to assign the quantity and name to the resource. Found resource widget. If it does not find the resource already set up, we then can use this same functionality here to create something like that. This should work for our purposes. One more function in the container will create an acquire resource here, and we will have the same two inputs as in the resource. We'll do the resource, the collectible, and amount, and integer. Now we'll first run the update and see if it exists. The return node will give us the resource widget. Taking that, we then cast it to our resources widget, because when we set up this output, we just chose widget object. We didn't assign it what type of widget object. And as long as that succeeds, which it will, we can then pull off of here and acquire the resource on the resource widget. We'll put the amount in there, and we'll put the resource in here as well. So now we should have this dynamic resource container that could have an unlimited number of resources. The only thing we did not do is specifically set an order of which resources come first or anything. It's basically the order the player acquires them in. And if you're designing a UI, you may want to specify exactly the ordering. This will get something up and running. So now with all of this compiled, saved, let's go to our main widget. Select the resource container, and let's make it a variable. Let's just rename this to resource container. Compile that. Then in our player controller, let's create a function here to acquire a resource. Drag off our HUD main variable, get the resource container. And then from here, we're going to acquire a resource, drag that in, take this, drag it into the input, just like that. Now the last thing, we need to call this function from our character. So let's go back to the tutorial, open up our character. First go to our event graph, and off of the receive controller changed, right click off of the PC first game in our cast node and create a variable. So now we have a reference to our player controller. We're going to use this reference often, so it's good to have. Then we can go into our acquire collectible function, drag in our player controller variable, look for the acquire resource function that we had set up in the player controller, hold control, and then click here, and we can drag the connectors into the new function. We can delete the list our collectibles function from here, take the type from the input here, plug that into the resource. And then what we need to do is create a local variable for current amount of this type. We'll just make it an int. We need to drag it onto this pin here. We're going to set this local variable with the current amount from this pin. And then we also need to add it up here and set it there as well. This local variable, we're just creating it so that we can figure out what the current amount is. Since there's two branches to this function, it will get the current amount from whichever branch it chooses. And then we can take that local variable and plug it into this amount there. Compile and save. Now cross our fingers and everything should work. Let's just check it out. So if I hit play, there's nothing here. Bricks, star, coin. There we go. Perfect. First try. What we can do to make this slightly better, first is in our data, enum, collectibles, make bricks not plural because the other ones are not plural. And then come into our resource widget. Off of the text, we can format text. And with brackets, I'll just do a variable like an X, and then I'll put an S colon. It'll make it plural with a colon. I plug the string into this X here, so the X will become the name of the resource. There'll be an S with a colon at the end. So now they're all plural. Also, go back into our resources in the designer. We can take the number, we can change the color. We can also make the font size a little different. Maybe it'll be 36, a little bit bigger, or 42, something like that. Taking all of these collectibles, hitting the end key, make them a little lower. Now I don't have to jump around. Now that we've deleted out the resources from our resource container, it's hard to visualize how things will look, especially if I go to the main widget, it looks blank. One thing we can do is go to the graph in the resource container, do event preconstruct, and we can drag in our update resource, add a coin to it. Now it will have that in here. And then on event construct in the container, we can clear children. Preconstruct is something to visualize in the editor for the most part. Construct constructs it in the game when you're playing. So then on construct, we'll just clear all the children and it'll be as if it's not there at all. So it still works. But now we can see in main, our coins are there. We can even add more than one of these. If we want to see all three, you could just chain them together like this. And when we clear children, make sure to clear the mapping. So there are a couple things we can do to make this a little better. We can initialize the UI and show the resources with a 0 from the beginning, and then we can also keep the order the same. So the first thing should be fairly simple. In our player controller, we'll open that up. So one way we can do this is in the event graph, depending on when we want the interface to display, it could be on possess, or we can also do on begin play. It really depends how your game is set up and when you want the interface to show to the player. For simplicity, I'll do it on begin play, and I'm going to create a function and I want to call it init for initialization. Right click anywhere and type e collectible, which is our enum. There's a function here for each e collectibles. We could drag that in. We could just drag in the acquire resource function we had created earlier and connect it like that and leave the amount 0. And that should add all of the resources to our interface and display them with 0 amount. And the ordering will follow the order of the enum. That should tackle both situations. Pile and save that, and then go to the event graph, call the init function on begin play. That's a simple way to handle that. So now on begin play, we get all of the resources displayed. Just like that. And then we should be able to go to the enum, put the bricks above the stars. The ordering should change to now coin, brick, star. And let's make sure they still work. Now, just by sorting the enum, we can control the order of how they are displayed. Coming up in part 3, we'll create some new actors, some switches, levers, doors, and platforms. We'll communicate between actors with dispatchers and interfaces, and a whole lot more. Thanks for following along this far. Please subscribe, and if you'd like to get the project files, head on over to Patreon and check that out.